We built a time machine. It cost $10 billion. It was made of gold beryllium and folded like origami. We launched it to a point 1,000,000 miles from Earth, and we pointed it at the deepest, darkest patch of nothing we could find. We called it the James Webb Space Telescope, and the goal was simple: look back in time. Look back 13.5 billion years to the cosmic dawn. We wanted to see the first galaxies. We expected to see toddlers. Small, messy, dim blobs of gas, slowly learning how to be stars. We expected a nursery. We were wrong. What looked back at us from the darkness weren't toddlers. They were monsters. Galaxies that were too big, too bright, and too mature. They shouldn't have existed. It was like digging into a layer of rock from the dinosaur age and finding a titanium iPhone. It broke our models. It panicked the scientific community. Headlines screamed that the Big Bang was wrong. But now, the panic is subsiding, and something much more interesting and much more terrifying is taking its place. The universe didn't break. We just discovered that the early cosmos was a place of violence and physics that we can barely comprehend. Today, we are going to meet the little red dots. We are going to uncover the theoretical monsters known as quasi-stars, stars that are actually black holes in disguise. And we will ask the question, did time itself flow differently at the beginning of the world? To understand why astronomers were sweating in 2023, you have to understand the speed limit of the universe. Not the speed of light, the speed of gravity. In the standard model, the universe starts as a smooth soup of hydrogen. Gravity is weak. It takes time, hundreds of millions of years, for gravity to pull that gas together into clumps, and for those clumps to ignite into stars. It's a slow process. It's like building a sandcastle one grain at a time. But JWST saw galaxies like ZFULA3 and the universe breakers. These things looked as massive as our Milky Way, but they existed only 500 million years after the Big Bang. To get that big, that fast, they would have needed to turn almost 100% of their gas into stars instantly. That's physically impossible. Usually, when stars form, they blow the gas away, stopping the process. It's a self-regulating system. So we had a paradox. Either our clock was wrong, or these objects were not what they seemed. Enter the little red dots. In 2024 and 2025, we started getting the spectrum of light from these objects, and the story changed. They aren't galaxies filled with trillions of stars. They are tiny, compact, dense. They are hiding a secret. There is a theory resurrected from the dusty archives of astrophysics that explains them. It involves an object that sounds like pure science fiction, the quasi-star. In the modern universe, a gas cloud breaks up into many small stars. But in the early universe, the gas was pristine, no heavy metals to cool it down. So, a cloud 1,000,000 times the mass of the sun could collapse all at once. The center becomes incredibly dense. But, and here is the twist, it happens so fast that the core collapses into a black hole before the outer layers can blow away. Think about that. A star the size of our solar system. But in its heart, there is no nuclear fusion. There is a black hole. This black hole is eating the star from the inside out. It is a cannibal star. The energy from the black hole feeding on the star pushes out, keeping the star inflated. It creates a balance, a terrifying balance. These objects would be millions of times brighter than our sun. They would look like little red dots to a telescope 13 billion light years away. This solves the impossible galaxy problem. We thought we were seeing the light of 1,000,000,000,000 normal stars. In reality, we were seeing the death scream of a single monster, being devoured by its own heart. But how do you feed a monster that fast? If you try to dump gas into a black hole, it starts spinning. Centrifugal force pushes it out. It's like trying to flush a toilet that's spinning too fast. The water won't go down. Nature needed a way to break the speed limit. Theoretical simulations have shown a mechanism called bars within bars. It's a Russian doll of gravity. A large gas cloud becomes unstable and forms a bar. This bar funnels gas to the center, where it gets too dense, becomes unstable, and forms a smaller bar. This repeats. This fractal cascade funnels gas into the center at supersonic speeds. It bypasses the speed limits. It allows a black hole to grow from nothing to 1 billion solar masses in the blink of a cosmic eye. The early universe wasn't a slow construction site. It was a factory of runaway collapse. While the quasi-stars glow red with death, another anomaly glows blue with life. The blue monsters. These are galaxies that are forming stars not at a steady pace, but in violent, stochastic bursts. We call it stochastic star formation. In the early universe, gravity was crushing everything together. Cold streams of gas punched through galaxies like spears. This caused stars to form all at once, in an explosion of light. And here is the most mind-bending part. The physicist Avi Loeb proposed a theory called the Habitable Epoch. Today, space is freezing, minus 270 degrees Celsius. But 15 million years after the Big Bang, the afterglow of creation, the cosmic microwave background, was still hot. It was about room temperature. For a few million years, the entire universe was a Goldilocks zone. You didn't need a sun to have liquid water. You could be a rogue planet drifting in the void, and the heat of the universe itself would keep your oceans warm. Imagine that. Life, developing in the dark, heated by the dying light of the Big Bang. Did it happen? We don't know. But the conditions were there. Why don't we see quasi-stars today? Why aren't there monsters in our backyard? Because they died to build us. The quasi-stars burned out. The black holes inside them became the supermassive black holes that now anchor the centers of all galaxies, including our own. The violent blue monsters settled down, their gas used up, spiraling into the orderly disks we see today. We live in the boring era, the quiet era. But when you look at the James Webb images, at those faint, pixelated smudges of red light, remember what you are looking at. You are looking at the furnace where the structure of reality was forged. You are looking at black holes eating stars from the inside out. The universe isn't broken. It's just much, much wilder than we dared to imagine.